enjoy that dynamic movement. All right, so now with all the hogsheads in place, you met the requirement of the data sheet of a strut no greater than 5 feet apart horizontally. Now they can dance back and forth there all they want. Okay? Questions so far? Make sense? So we've done two scenarios. Simple systems attacking a corner, switched them so each group gets to do it, created a gap. Second scenario did the double whalers, talking about all three conditions of trench walls. Now here, we tear the whalers out. So take out the hogsheads, take out the sheeting, take out the struts pressurizing the whalers. Now we're going to transition into, squeeze by here, into the L. Once again, hands-on with the data sheets. Have them pull out their data sheets. So now we have two different depths here. We've got an 8-foot depth and a 10-foot depth. So the whaler stays the same, it's going to be a 4x. But if you want to change it up, throw out some different numbers. Let them use that. If you're thinking that they're not really comprehending these data sheets, play with it a little bit. But now we're going to describe how we're protecting this outside corner and inside corner. So I keep all the simple systems in place. If you have the time, you want them to tear that one apart and rebuild it next to it, have at it. Usually I don't have the time, so I'm just going to have a ladder there and a ladder there, and they're just going to build separate, okay? But the whole emphasis is to get them into this L, all right? This one is how it would be if all they're doing is attacking that L. So the systems are butted up. So the ladder's on there. Now we talk about when do we require a single whaler as opposed to a double whaler. All right, data sheets, right? So you've got the whaler going here. The whalers have to be pressurized minimum how many spots? 2 spots, right? So pressurized. But from that pressure point out to this surface here, how long is that ear? And does that matter? When can it be a single ear as opposed to we need 2 ears sticking out there, that double whaler? So this team that's building here, they're actually responsible for inserting this panel, this sheeting, because they can't do anything till this whaler's going all the way across and touching it. They're not pressurizing into this wall, right? They're going across this face, they're protecting this face, but they can't continue building until they have this sheeting in. So this group, the same thing. They're responsible for inserting this sheeting. They can't do anything until they're touching this guy running the full length. So from that pressure point out to the end here, what's the requirement for strut spacing? Look at the data sheet, 8 foot, 4x4, it's every 5 feet. So do I have more than 5 feet out here? In this scenario, yeah, you do. So we need one near the ends, once again, depending on how the trenches were cut. So I put my double whaler in here. This group, they're putting it in. 10-foot trench, 10 feet, 4x whaler, it's every 4 feet, horizontal spacing. So from that strut there to the end of the ear, is it more than 4 feet? Yeah. So if it was less than 5 feet here, less than 4 feet here, we could do single whalers, right? Single whalers can come in, one could be high, one could be low, or they could both be touching, doesn't matter for a single whaler. But now if it was less than 5 feet here, less than 4 feet here, that cross-grain strength of that 4x4 is strong enough at 2 feet down every 4 feet till we're within 2 feet from the bottom of the trench. It's strong enough to take care of that lateral force that these walls are going to push against it. Okay, that whale strut configuration. If it was greater than 5 feet, 5 feet or greater, and 4 feet or greater, now I need a strut placement according to my data sheet. How am I able to put a strut out here? Double whale, double whaler. So now you see that these whalers are pretty in line. One has to go low, one has to go high. You can't butt it into it because now it's not protecting the entire face. So you got to make sure, well, we're hitting. Well, lift one up or put it on top. So they run it all the way across. Now at 4 feet over, they need a hogshead. So you see this condition here, we'll get this. It seems like a stupid question, but it's like, well, how do I put my hogshead there? I got to lift my whaler to get that hogshead underneath it, right? Well, does it matter whether the hogshead on top or on the bottom? So it goes on the bottom. So we've had guys and gals scratch their heads for 5 minutes trying to figure out how to get that stupid hogshead in.
Pretty much, if you have a 36-inch trench, you have to get that.
That's the whole idea. Yep. Now, in your class, if you want to institute a 6x, because now you've got got that 10 feet of ear sticking out in the 8 foot, or I believe it's 8 feet of ear sticking out because of the 10. The benefits of that, right? Not many crews have 6x. I've had departments come through our classes back home. We're putting 6x on our rigs. Hey, have at it. It's an option, right? That's why it's there. But not many crews have it. We only have 4x for mine. So, for my actual tech rescue. So, but yeah, if you've got it and you want to institute, maybe put 4x on one side and 6 on the other. Thrust blocks because you're thinking inshore?
Yeah, you don't have to meet.
Yep, not necessary.
Don't.
Because remember, before we were teaching this, we only did single whalers. So we put a thrust block there to keep that from moving, right? Put a thrust block on this one to keep it from moving. Now it all goes by the data sheets. It's whether or not we need a strut. We're not worried about thrust blocks, we're worried about struts. So what's the data sheet tell us? Do I need a strut requirement? Yep. How am I going to get a strut in that position? Double whalers. So now instead of that single thickness whaler, well, a single 4x4, I basically thickened it by a second whaler, right? So now if this wall were to go, it flexes this first whaler, transitions it, double funnel, right, onto that other whaler. So now Joe, spinning this propeller, that's the other engineer, spinning this propeller, killing lab rats, that double thickness there will take up that lateral force because obviously you have longer ears sticking out.
How about, because we've also done diagonals into the corner. Does that count as a strut?
No diagonals. All right. So once again, think of rakers, right? Slope floor, rakers. How are we putting diagonals in there? How are we accommodating that? Got a lot of force there. We're not doing any, rated cleats. And then how are we anchoring off the panels? Now we've got an angled strut going there. If this were to push, it wants to push that panel. And that panel isn't positively attached to the wall. It's only against the wall under friction due to the pressure.
Might be a stupid question, ask it anyway. We got an older rescue that we're only able to carry 8-foot lengths of 4x. Is there any way to splice?
We are trying to get that done right now. We were really hoping that Joe was going to be here because Stan and I, that's one of our questions, is we want to splice whalers. It seems like an easy question, and I'm going to say, yeah, we can do it. But I'm not the engineer. It's not my stamp, and I'm not going to tell you to do it because I don't want the liability. So, but yeah, we're trying to get that, and as soon as we do, we will publish it. We will have that out. So yeah, because my tech rig home, I've only got 10-foot 4x4s. That's not a very long whaler, so I'm going to be using ladders, right? And I hate ladders as uprights in whalers. It's a tool, but I'm not a fan of it. So if I can take a 10-footer and a 10-footer, make a 20-footer, or even, I've got 2 different designs in my head, so it all depends on what Joe comes up with. Whether it's a butt splice and a connection, or an overlap and a connection, putting the strut obviously at that splice or overlap. Seems like a simple system to me, but we don't have it yet. But you're on the right path. Yeah, we want to get that.
And your previous question before, you're not doing
no
diagonal
angled struts
anymore.
Nothing angled. The only angled cut you're putting here is that little cut back on those cut the fit. So, all right. So we've got their hogsheads in. Put that. If you've got the time, obviously you go lower. A lot of times I've only got enough time to put the top in because I do everything else fully built out. The nails really slow things down, as you know. And then we talk about, okay, how do we backfill? Whether we're forcing the plywood against the wall or backfilling with sandbags, airbags, salvage covers. Okay. Let's see what else. What am I missing here? Questions? So once again, this is your class. We are obviously objective driven. We're not like going to come up with things and say, let's do this instead. You fulfill all the objectives. You get done an hour early. Hey, you're done an hour early. We have some phenomenal classes. We've had classes where we've been there till 6 at night. Okay, so you know how it is and how things can be. But for me, with this group here, this L trench, I've given them every different consideration they can come across. I want them attacking the corner, so they hate corners and they'll hopefully back away from it when they leave the class, right? I give them double whalers on a slot trench, intact walls, one wall, both walls gone. And then we've done the L, okay? Whether the corner is intact, the corner is gone. You talk about all those different configurations and situations. And you always want to re-emphasize, you're always reevaluating your trench conditions. Right?
6s for whalers. We've used those in the
We've
past.
used them in the past. I've done them extensively. You put the 6 out. Now I've got under 6 by strength, but it has a huge rocking potential, right? So Joe rated only 6 by, so we don't have the 4 by 6 potential. Could you use it? I'm going to say, yeah, you can, but you own the liability if something fails, right?
Still have to go back to the 4x4.
Well, I wouldn't even say 4 by 4. I would worry about, you know, the rocking instability part.
I mean, if you were to
By
use
using
a 4 by
the
6.
4 by.
You're using the 4 by, right? So now it's nice and stable, but you only have, if you have them, yeah. So yeah, I can't legally, realistically tell you you can get that 6 by rating by putting it out. Okay, it's got to be a 6 by 6, 4 by 4, 2 by 12. Those are our 3 whalers we have. The ladders, we're going to use 4 by cribbing, so it's rated at the 4 by whaler.
When you're teaching the class at all, do you ever have, or do you teach them put the whale in with your first strut, or do you almost always do this technique where you're strutting your panels first and setting the whale on top?
Oh, so to put the
Simple
whalers
system?
in originally without a simple system, you can talk about it, and if you have time, if you want to do that, once again, this is your class, as long as you get all the main techniques in. Because by doing that, they will see how long it takes before somebody is down into that trench digging. So I'll talk about it, but I will never have them do it. Okay? Because with the simple system, clean part of the trench, even if they got to reach out, you know, here's their sheeting, reaching out with a shovel, bucket, whatever they got, somebody's doing a decent job down there uncovering that victim instead of twiddling your thumbs because you're holding, there's a rope here, rope there, rope there, rope there, somebody's on a ladder, somebody's on a ladder, you know, so you got 6 people really doing nothing, right, trying to get these whalers in. So, once again, your class, if you have the time to do it that way, have at it. Others? Aaron, anything? Ellis, talked a little bit about the others. Once again, remember the ratings on that, 15,000 pounds. It will outlast any piece of 4 by you put into it. Greatest rating I get a 4 by 6 feet or less, that's 12,000, right, in grain strength. For the nail requirements on it, you've got a bunch of nail holes on the buckets. However, 1 nail's all you need. Halfway in, roll it over, because you only need that 1.94, right, or 2 inches into the piece. That doesn't even add any strength anyhow. It's just if you're handing it down, it doesn't fall apart. Make sure it's all the way seated in. Remember, exposed threads, 6 inches only. The one negative thing about the Ellis screw jacks is you can overextend it and create that unsafe knuckle and it can fail. So if they have more than 6 inches of exposed. On mine, for my tech rig back home, I tape up 6 inches and spray paint the last 3 inches, some obnoxious fluorescent paint. So they start seeing that paint, they know they're maxed out, okay? So it's unlike the pipe where I can tack weld, put a piece of duct tape, and those ears stop, right? So I don't overextend it or create an unsafe knuckle in that pipe. So fluorescent paint, the one negative, there's no safety stop there. The old Ellis, remember, you subtract 11 because it's a little bit more than 10 inches from the bottom of the base to the bottom of the bucket. But the newer ones, and by newer I mean 15 years on, I guess it is, because we do have a couple old ones on our trench trailer, 9.5 inches. So I just put subtract 10 on my bucket, so it's a nice big reference for the guys and gals using it. Hand tight, turn, 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 don't have to be Hercules, and then 1/2 to 1 full turn. Once again, it should be a solid fit. You want to re-emphasize to all your students that every strut they're putting in, for the wedges and for that cut to fit, that solid thud should be heard, right? And you shouldn't be able to just wiggle that thing. So when everything's nailed off, it's not going anywhere. But if it's loose, no, that's not appropriate. So you leave that in, it pushed things tighter to the wall, cut 1.5 inch, maybe an inch bigger, whatever's needed. Pressurize it on top or to the side of it, it drops out, throw it up top so you can use it elsewhere. For the wedges, you're subtracting for 4, pressurize, you got that 6 inches of travel. That's another thing. Where they're nailing off these wedges onto the uprights. Because you get a lot of groups that'll just nail it like that, right? So you use a lot of wasteful wedge because it's overhanging here. I've got to pressurize somewhere in between this upright. Well, that's not very effective. Also, where they put that nail. If I put a 16 penny nail here, it's not doing any effective use, right? Because that 3.5 inches is almost being all used up into the original piece. Down here, it tends to crack, so treat it like a 2x4. So somewhere in this area here is where that nail should go. So 2 nails here, and I overhang